All right, so before we get deep into mechanisms, we first have to make sure that we understand how to read them. And so at this point, through the resonance and the acid-base mechanisms, we should understand this decently well, but let's just do another double check. And so you have to be able to follow your arrows. So let's start it off with a reaction that we know about, and that's an acid-base reaction. So we're gonna take ammonia here, we're gonna combine it with HCl, and then we're gonna get a product. And so the arrow pushing looks like this. The lone pair of the nitrogen attacks this hydrogen, and then it breaks this bond right here. And so what you should be able to do here is identify the products and their formal charges, right? What goes on this right side. So let's go ahead and analyze it. The first arrow that we see is coming from this nitrogen to this hydrogen. And so what's occurring here is we're forming an NH bond. Right? So on this other side, we can write an N and we can make an H, right? We formed this bond right here. And we didn't mess with the H3 on the nitrogen, so we can leave that alone. And then if we take a look what happens on this other side, right, we broke this bond. So this hydrogen is no longer attached to this chlorine, and then these electrons went on this chlorine. So this chlorine is by itself. And so there's your atoms, but you also have to think about the formal charges. Right? So if we think about this nitrogen, what's the formal charge on this nitrogen going to be? Well, if we take a look at our mechanism, right, over here it's neutral, right? So we'll say it starts off with a 0 formal charge, and then it loses electrons, right? It loses electrons. So if it loses electrons, it's going to get more positive. So it's going to go from 0 to +1. If we think about the hydrogen next, the hydrogen gained some electrons through this movement, but then lost some electrons through this movement, and so it's a net 0, right? It gained and it lost, so it keeps its 0 formal charge. And then finally, we're thinking about the chlorine. The chlorine, this bond broke, and both of the electrons on this bond went to the chlorine, so the chlorine gained electrons. If the chlorine gains electrons, it must be negatively charged. And so this is what I mean by following your arrows. If you have what's shown on the left, you should be able to describe what the products on the right are going to be. Let's take a look at another example. In this case, we have this carbocation. Then we have this bromide. And this bromide is going to attack this carbocation. So again, you should be able to envision what the products are going to be. So here we can see we're forming a bond from this boron to this, or bromine to this carbon. So we have this motif right there. And then we have to think about what kind of charges we have. Well, so this carbon was originally positive, and then it gained electrons, right? This arrow is moving towards it, so it gained electrons, and so it's going to become more negative. So in this case, it's going to go from positive to 0. When we have one bond moving, it's always going to be a change of 1 in the formal charge. And then finally, this bromide, right? It's negatively charged here. And remember, this negative represents a lone pair. And so here it's negative, and then it loses electrons. So this bromide went from negative to losing electrons. That means it's going to get more positive, and so it's going to go towards 0. So in this case, both of our products are neutral. We could also have the reverse of this reaction occur. Right? And we can think about what our products are going to be. We see that the electrons in this bond are now leaving and going onto the bromine, so we're going to break this bond. And so you can see I've drawn that bond being broken there. And then if we think about what the formal charges of everything is going to be, right? This carbon was originally neutral, and then it lost electrons because the electrons in the bond went to the bromide. And so this will be positively charged. And then this bromine over here is neutral, but then it's gaining electrons, so it's going to be negatively charged. Let's take a look at another example. Here we're going to have this pi bond. So our electrons are coming from this bond instead of an atom. That's a little bit different, or instead of a lone pair. And then the electrons in this HBr bond are going to go onto this bromide. And then we can think about what the products are going to be. First off, we can see this bond is going to be broken, so that'll be pretty easy. We know we have this Br here, and the Br was neutral, and then it gained electrons, so it'll be negatively charged. And then we're thinking about, okay, these electrons came from this pi bond. This pi bond is being shared by both of these carbons. So which one of these carbons is going to form the bond to the hydrogen, right? So we can have actually two options here. We can say that the carbon on the right formed the bond with the hydrogen, in which case this other carbon now has a positive charge since it lost electrons. This carbon on the right here didn't change charge at all, right? It lost electrons here, but then it just regained them by forming this bond with the H, so it didn't really lose any electrons. And then the other option was to have this carbon over here bond with the hydrogen. And that would result in a positive charge on this carbon. And so for right now, you don't know which one is going to happen. Later on, we'll learn some rules and we'll find out that one of these is correct and one of these is incorrect. And in this case, the top one is the correct answer. But for now, you wouldn't really know that. Let's take a look at another example. Attacking this carbonyl here. And so we're thinking about what bonds are being formed. Well, we're getting a carbon-carbon bond being formed. And so that's our bond right there. Then there's a nitrogen right there. And then we're thinking about what's going on here, right? We have only one of these bonds breaking. So now we go from a double bond to a single bond. And then we can think about what's going on with the charges. This carbon was negatively charged, but then lost electrons. So it's going to be neutral over here on the product side. This carbon over here both gained electrons and lost electrons. So it's going to stay the charge that it was, in this case, neutral. And then this oxygen up here gained electrons. So it's going to have a negative charge. And so that's your product right there. One more example. And so we can think about what the product is going to be over here. And so first thing we can see is we form an OH minus H bond. And so in that case, we're forming water. Right, so there's that bond formed right there. If we think about the formal charge, this oxygen lost electrons, and so it goes from negative to being neutral. This hydrogen gained electrons through this upper arrow, but then lost electrons through this lower arrow. And so it stays whatever charge it was, in this case, neutral. So we've got neutral water there. And then we take a look at what's going on with this bond over here, right? So this bond is being transferred from this CH bond to this CC bond. Right, and so this CC bond is going to gain 2 electrons or gain another bond, and it's going to become a double bond. And then finally, what happens over here? Well, we're losing this bromide, so that's going to become a Br minus. It's taking its electrons with it. And then both of these carbons here, they both gained and lost electrons, so those cancel each other out, and so they're neutrally charged over here. And so that's kind of where you want to get comfortable at this point. Before we start talking about mechanisms, before we start talking about how and why these things actually happen, you first have to be able to read these arrow diagrams and be able to follow your arrows.